Hello everyone, and welcome to Network Labs. In this video, we will start simulating a service provider network using Juniper routers. In the diagram, I used 5 Juniper routers within the service provider network, and Cisco for the customer networks. PER1, PER2, PER4, and PER5 will all serve as provider edge routers. All the PE routers are connected to the provider router, which is PRR, and the route reflector as well. The topology is connected in multiple rings for redundancy once a link is down. Primarily, all the traffic from the PE router will pass through the P router. For our tasks, Customer 1 is requesting end-to-end connectivity between its sites via Layer 3 VPN. While Customer 2 is also requesting end-to-end connectivity between its sites via Layer 2 VPN. We will follow the steps below to achieve our tasks. IP addresses are pre-configured on all the routers to save time. Let us start the configuration by building the basic backbone step by step. First, deploy IGP, which is OSPF. IGP is used to share routes throughout the entire topology. Let us begin the configuration in PER1. Link interfaces are up. First, enter the configuration mode. Then type Edit Protocols. As we can see, the protocol is empty. Type Set OSPF Area 0.0.0.0, followed by interface loopback 0 unit 00 to passive. Edit OSPF protocols. Then advertise each inside interfaces to OSPF. First is the link facing PER4. Set each interface type to point-to-point for faster convergence. Then the link facing PER2. And the link to the P router. Type Show to verify the configuration. Type Show compare to match the candidate configuration to the previous or active configurations. Then commit check to see if the configuration will succeed. Before we proceed, we need to increase the metric or cost on the interfaces facing PER2 and PER4 to force the traffic via PRR primarily. Retain the cost facing PRR to default. We can now commit the configuration. The configuration is similar to the remaining routers. Copy the configuration in PER1 and edit the other details. Paste the configuration to the other routers. Start in PER2. Next router is the P router or the route reflector. Then PER4. Last router is PER5. OSPF IGP is deployed. Let us verify if OSPF adjacencies are established. Type Show Route Protocols OSPF to check the routing table. As we can see, in PER1, the loopback addresses of the other routers within the network are now learned. Conduct ping testing and traceroute to check the end-to-end connectivity. Ping test and trace route are also successful from PER1 to PER5 and traversing via PRR primarily. That is all for basic OSPF configuration in Juniper routers. Next, deploy MPLS-LDP to build LSPs within the network. First set each inside interfaces and activate MPLS. Type set interfaces followed by the interface port number, then family MPLS. Do this to all the remaining interfaces, including the loopback, optionally. Next, enable MPLS protocols on each inside interface. Copy the configuration of PER1 and paste to the remaining routers. Edit the other details and paste to PER2. Next is the P router. then PER4. And the last router is PER5. MPLS is activated on all the inside interfaces of each router within the topology. After enabling MPLS on each interface, enable LDP or Label Distribution Protocol to build LSPs in the topology. Let us start in PER1. Type Edit Protocols LDP. Then activate each inside interfaces. Again, copy the configuration and edit the other details. Paste it to PER2. Next in PRR. Then PER4. And the last router is PER5. LDP protocol is activated within the network. Our backbone is almost done and ready to cater services specifically for VPN routes. Next to activate is BGP or iBGP and MPLS-LDP within the network, so the routers can carry VPNV4 routes from one PE to another PE router. Verify the existing BGP configuration. Type Edit Protocols BGP. Type Set Group followed by the group name, then the type which is internal for iBGP. By the way, we will be using AS number 650002 within the network. Edit the BGP group. Set the local address using the loopback 0 address for establishing BGP sessions to peer or neighbors. Set the neighbor or peer router, which is the route reflector only. Activate or enable family iNet or IPv4 unicast. Then iNet VPN or VPNV4 unicast. Next, on the PE routers, configure a route policy to set the next hop address when they share routes into BGP, for the other routers to know where the next hop is. Starting in PER1, set a policy option using a policy statement. Type Set Policy Options followed by policy statement, then the name. Use term 1, then set Next Hop Self. Edit Protocols BGP. Then apply and export the policy within the BGP group. Committing the configuration fails. One more thing to do for BGP is to create routing options and define the router ID and autonomous system. Type Set Routing Options followed by Router ID. Then use the loopback address. Next, set the autonomous system, which is 65002. We are done with the basic iBGP configuration in PER1. The commit check now succeeds. Commit the configuration, then copy and apply it to the other PE routers. Copy the BGP group configurations. Then the routing options. Apply the same configuration in PER2. The commit check fails again since the policy option is not created. Go to PE1 and copy the policy option for the next hop. The commit check now succeeds. Commit the configuration, then proceed to the remaining PE routers. Go to PER4, then apply the same configuration. And on PER5. In PRR, the configuration is different since it acts as the route reflector router. Under the BGP group, set the cluster followed by an identifier to tell within the group that it is a route reflector router. Then define each PE router as the BGP peer or neighbor. Apply the updated configuration in PRR. Commit the configuration. BGP for IPv4 and VPN-V4 family unicast is done. Let us verify the BGP neighborship status in PRR. Issue the command show BGP summary to display all the BGP summary information of all routing instances. As we can see, the BGP neighborship to all the PE routers is now established. In PER1, we have an established adjacency facing the root reflector router for both the routing table of INET and BGP Layer 3 VPN. Now, multi-protocol BGP is up and running. In the next video, we will start bringing MPLS Layer 3 VPN. I hope that this is informative to you, and thank you for watching.